It's going to work the same, guys. We're going to have questions up here. I'm going to put quite a few questions up. I want you guys to just give me your answers, and then we'll add anything that we learn into our notes here. So we just learned some units. So we'll look at current, units for currents. Oops. Can you guys hear me okay? Is it loud enough? Okay, thank you. So what about the units for potential difference? Resistance is another important one. Potential difference is volts. Good. Resistance is ohms. It's got that weird symbol, the omega symbol. We also have power. What's the units for power? Thank you very much. It's going to be watts, W. Okay. So we'll just put that in there and go back to the question. So answer the first one, amps. That's absolutely right. Next question, which of the following is a conductor of electricity? A, B, C, or D? Let me know. Pick your answer, comment, and tap the screen a few times, please. Okay, so we got most people going for B. That is correct. That's the metal. Metals conduct electricity the best. They have free moving electrons, C of delocalized electrons, which carry electricity. And that's the correct answer for that one. Okay, so we've got an exam question here. We've got to sketch a current against potential difference graph. So we call those IV graphs. There's 3 different IV graphs you need to know. So let me draw them. Let's go to our notes and let's draw all the IV graphs that we need to learn. So there's one for a resistor. There's one for a bulb. And there's one for a diode. So how does the one for the resistor look like? A resistor, or an ohmic conductor sometimes it's called. Straight line through the origin, yep. So if you were asked in an exam, you would get your ruler out and draw a straight line through the origin. So yeah, we're covering electricity today in physics. So that's what a resistor or ohmic conductor would look like. So next is a filament lamp or a bulb. We call it a bulb sometimes, but I think in your exams you'll see it as filament lamp. How would this one look like? And then the last one's a diode. It is a curve. It's like a S-shaped curve, this one. So it does go through the origin and it's pretty straight in the middle part. So that part is pretty straight, but then it curves off on the edges. So as you increase the potential difference, it increases as well. So these are IV graphs. So that means we've got I on the y-axis and V on the x-axis. Then the last one is the diode. This is the one that looks a bit funny. Diode, you need to kind of understand what a diode does. A diode only allows current to flow in one direction. So here on the V graph, on the potential difference graph, we've got the positive side on this on the right, negative side on the left. So if we say the positive side is the correct side and the negative side is the wrong side, if it travels in the wrong direction, there's going to be no current flowing through it whatsoever. But as soon as it starts traveling in the positive side, the current increases. That's because it allows current to flow in that direction. So yeah, these are the shapes to memorize for the IV graphs. So let me zoom out a bit. Let's go back to our question. Sketch an IV graph for the filament lamp. So that's the second one that we talked about. So it's going to curve, then it's going to go through the origin, and then it's going to curve again. That's 2 marks. So we'll look at the mark scheme in a second to see what they're looking for exactly. Second part, part B, figure 2 shows the circuit with 2 identical filament lamps. Compare the currents of I1, I2, and I3. What can we say about these? We got I1, I2, I3. What can we say about this? So are there any of these 2 that are equal? Or so someone said they're equal. Are they all equal? All 3 of them equal? I don't think all 3 of them are equal. 2 of them are equal. L2 and L3. I2 and I3. Yep, good. So I2 and I3 are equal because what's happening here is the current is being produced by the battery. So let's say that's like 10 amps, for example. So we've got 10 amps coming out of the battery. It's traveling this way. And then when it reaches this point here, it splits. Half of it goes this way, the other half goes this way. And it's split in half because these 2 lamps are identical. So the 10 amps would get split into 5 amps here and 5 amps here. So you've got exactly the same going through there. So one thing we can say, so remember this is a 2-mark question. So 2 marks we need to, 2 points we need to say. So first one we can say is I2 is equal to I3. And then, yep, someone said it. To get I1, you sum up I2 and I3. Yeah, that's right. Because 5 amps plus 5 amps is equal to 10 amps. So that's basically saying I2 plus I3 is equal to I1. So if you write that, you should get the mark. I2 plus I3 is equal to I1. The reason for that is because, remember, current splits in a parallel circuit. Whenever it reaches a junction like this, the current will split. So let's take a look at the mark scheme, what it says, what we want exactly. So first one, a curve in the first and third quadrant only. So first quadrant is here, third quadrant is there. Passing through the origin, yes, we did pass through the origin. If we look back, yep, we did pass through the origin. So that was fine. Second question, I1 is equal to I2 plus I3. Yep, we got that mark. And then I2 is equal to I3. We mentioned that as well. So we get our 2 marks and 2 marks there, 4 marks. Where did I get the numbers from? Which numbers are you talking about? Are you talking about I2 and I3? That's given in the question. So you see here, we've got I1 here, we've got I2 here, and we got I3 here. The numbers in the circuit, no, I made those up. These are made up. I just said if we had 10 amps, it would be 5 and 5, but it could, we don't know what it is. It hasn't told us in the question. It could be 100 amps and 50 and 50. So I just made that up just to explain it a bit easier. Hope that made sense, guys. So yeah, tap on the screen if that made sense and I'll move on. Thank you, guys. On to the next one. What does resistance of a component determine? What do you guys think? Comment the answer and tap on the screen a few times. Waves of revision. Yes, I can do waves of revision at some point. Okay, so answers so far. We've got C, we've got A. Getting a mix of answers here. We're getting more A's here. So resistance. The more resistance you have in a circuit, the less current you'll have. It directly affects the current. That's what resistance does. So if you have a low resistance, you have a high current. If you have a high resistance, you have a low current. So the answer will be A. Next up, what is the function of a fuse in an electrical circuit? I just put a poll, guys, just to find out what everyone's examples are. Can you just let me know if you can see it? I don't know if you guys can see the poll. Let me know while you're waiting. So yeah, so type the answer, tap on the screen a few times, and so we're getting C most of the time. So what's the function of a fuse? A fuse is designed to break the circuit when too much current flows. So let's look at our notes. What we're going to do is we're going to look at all these components. Fuse. Can someone tell me which one they think the fuse is out of all these circuit symbols? Of all of them. Can't see the poll. I've got people voting. I think it's on the left-hand side of the screen. There's like a little, it's a notepad with a tick. It's a symbol of a notepad with a tick on it. Below closed switch. Nope, it's not the one below closed switch. It's not the third one. Not the 8th one either. A fuse is the last one. This one here, that's a fuse. So people get confused between a fuse and a resistor. A resistor or a fixed resistor is this one. That's just a rectangle. A fuse is a rectangle with a line going through it. That's the difference between the two. They do look very similar, so make sure you know the difference. So fixed resistor is just a rectangle. Fuse has a line in it as well. Okay, so the answer for this is to break the circuit when too much current flows. What is the unit of resistance? We've mentioned this already. So I'm hoping everyone can answer straight away. Answer and tap the screen. It should be a quick one. Yep. Yeah, the line does represent the wire that breaks because that's the way a fuse works. There's a thin piece of wire inside, and if too much current flows through it, it melts. That wire melts and breaks. So that's a good way to remember it, actually. That's why it's got a line going through it. All right, well done, guys. Next, we have another question. So here, we've got a calculation question. Calculate the charge that flows through. So let's write down all the equations that we need to know for electricity. I think there's about 6 of them. Can you guys list out the equations that you guys know in the electricity topic? I'll write them all down. So we've got one which connects, yes, potential difference. V is equal to I times R. Potential difference equals current times resistance. So V is equal to potential difference. Keep telling me other ones that you guys have heard of and I'll write them down. I means current, and let me zoom up. And R is resistance. So yeah, this one's also known as Ohm's law. We've got any others? No? Okay, let me tell you the other ones that you could get. You could get the one for charge. Q is equal to I times T. You guys ever heard of that before? That's one you definitely need to know. Okay, yeah, well done. Charge is equal to current times time. So Q is charge. I, we've already said what I is at the top. T is time. Any others? There's a few more. So charge is measured in coulombs. Let's write that down here as well. Let's add this to this. Charge is measured in coulombs. Thank you, Amelia. Energy transferred over time. Power is equal to energy transferred over time. P is equal to E over T. So remember, this year you need to memorize all your equations. It's not like last year. So P is power, E is energy or energy transferred, and T is time again. So power written down, energy, we'll just add that here. I'll give you, remember, I'll give you access to these notes once I upload this live on YouTube. So that's measured in joules. Coulombs is capital C, joules is capital J. You can say work done instead, that's fine as well. You can say work done. So here, let's put energy / work done. We still have three more equations. So next one, we got P equals IV. You guys heard of that? It's another power one. There's 3 power ones in total. We've written 2 of them down. P equals IV, so that's power is equal to current times potential difference. The other power one is P is equal to I squared R. And there is one more that people often forget, is the one for energy. There's another equation for energy. E is equal to Q times V. So there we go. Every equation you need to know for the electricity topic. That's everything there, 6 of them. And we've got what each one represents as well. Okay, so we're going to have to use at least one of these in this calculation. So let me know. Let's go back to the calculation and let's see if you guys can figure out how to do this. So we've got calculate the charge that flows through the cell in 1 minute. It's always useful to underline all the information. Has a power of 3 watts and a resistance. So let's list out what we've got. Tell me what equations you think we need to use here. So we've got a charge, so that's a Q. That's what we're trying to find out. We got 1 minute, that's a time. We also have 3 watts, that's a power. And we have a resistance of 12 ohms. So what software is this? Is called Good Notes. It's on the iPad. So I'm using an iPad right now. So we need an equation. Power is equal to I squared R. Yes, that would be useful probably. So P equals I squared R, because you recognize that P and R needs equation together. So P is equal to I squared R. We'll probably have to use that at some point. Then we've got Q and T. So we need an equation with charge, which is probably Q equals IT. And that way we've got the 2 I's in both equations that can link up. Yeah, I'll put this on YouTube. Probably will take a while because I have to upload everything. It's going to be a long video, but I will eventually put it on YouTube. So yeah, which equation should we probably use first? We're trying to find out charge, so we're probably going to have to use this one second. So this is probably the second equation we need to use. First equation is this one. Because we got power, we've got resistance. So what we can do is we can work out what current is using this equation. Then we can put that into the second equation to work out what charge is. So the first step, to find out current, we need to rearrange this equation, the P equals I squared R, to make I the subject. I the subject. How can we do that? So let's write down P equals I squared R here. To make I the subject, let's first make I squared the subject, move R to the other side. We get I squared is equal to P divided by R. Now to make it in terms of I, we can just square root the whole thing. I is equal to P over R. This will give current. Yeah, we do need to convert the time, but we'll do that when we use that equation. We don't need to do that right now. So let's put those numbers in. So square root of power is 3, 3 over 12, and then square root it. Can someone do that in a calculator and tell me what that gives? I don't have the calculator on me, so I'm going to have to ask you guys to do it. So you've got 2. I don't think 2 is right for the current. 0.5. Yeah, I think it's 0.5. So answer is 0.5 amps. That's halfway through the question there. How many marks is this question? This question is a 6 marker. Wow, that's a lot. So I think this would give you about 2 marks. Next is to work out the charge. So we're going to use the second equation, Q equals IT. But like someone said earlier, we need to convert this time. This time is in 1 minute. We need to convert that into seconds. This equation only works if you use it in seconds. So 1 minute is equal to 60 seconds. So we can do 0.5 times by 60 seconds, which gives 30 coulombs. Okay. So this question actually carries on from the last one. Let me go back to the last one. So it's this one here. It's this question here. It asks, so the question asked, calculate the charge that flows through the cell in 1 minute. It wants you to find out through the cell. Okay? Let me redraw that diagram because this is the next part to that question. So you kind of need that to finish this question off. So what did we have? We had a cell, then we had 2 bulbs. 1, 2. Okay, so I think they called this one I1, this one was I2, and this was I3. Okay, so listen carefully, guys. So basically, this charge is only through one of the lamps here. So maybe this lamp, for example, that charge only goes through that lamp because the question says each lamp has 3 watts and 12 ohms. So the question's asking to calculate the charge that flows through the cell. So the whole thing here. So remember what we said earlier. What do you guys think we need to do to finish off this question? So this answer of 30 gives you probably 4 marks, 5 marks actually, because we've got the charge here. I don't know why I wrote Q. That's 30 coulombs. So one last thing we need to do is because there's 30 coulombs going through this, there's also 30 coulombs going through this bulb here. So what we said earlier is that I1 is equal to I2 plus I3. You have to add the 2 together. So the final answer would be 30 plus 30. So the final answer will be 60. I hope that made sense. So your final step here would be 30 plus 30, which is 60, and the units is coulombs. Let me know if that made sense, guys. Tap on the screen if it made sense. So let me explain one more time from the beginning. So we had 2 equations. The first thing we did, we've got the information for each lamp. So the first thing I said is this question, this is a part C question. So it carries on from the last question that we did. Last question, we had this circuit and we said the current here and the current here added together, so the I2 and the I3 added together gives you I1. I1 is the current through the cell. I2 and I3 is the current through the bulb. So we've got the information of the bulb. So what we did is we found out the current in the bulb doing P equals I squared R, and we got 0.5 amps. Then we used Q equals IT, which gave us 30 coulombs of charge in each bulb I2 and I3. So that means there's 30 coulombs here, 30 coulombs here. The question's asking the charge that flows through the cell, not the battery. The cell involves you adding both currents or both charges from the bulbs. So it's going to be 30 plus 30, which gives you 60. Hope that made sense. Let's look at the mark scheme, see where all the marks are from. So, yep, we did this. P equals I squared. We got our 0.5. Then we did 0.5 times 60. We got our 30. That gives you 3 marks up to that point. Then to get the Q total, so that's when you times it by 2, you get 60. And then the final mark you see over here is for saying coulombs, for putting the C in. So that's 6 marks. Hope that makes sense. On to the next one. What happens to the resistance if the length of a wire increases? Comment your answer, tap on the screen a few times, let me know. So I'm looking at the poll, so it looks like 77% of you, so quite a lot of you, are AQA. Few of you are OCR, EdXL. And I think we've got one person that's another. What's the other? What's the other? Just curious. So what answer we got? We've got B and C. So we've got people saying B, we've got people saying C. What happens to the resistance if the length of a wire? So basically, think about what resistance means. So resistance is how the currents, how easily the current stops. So the more resistance you have, the more the current will stop. So if you have a short wire, the current will flow through that wire quite easily. It doesn't have that far to go. It's because the wire itself has components in it that slows down the current. So if you had a really long wire, then it's got more of the wire to flow through. The current has more of the wire to go through. So that means it's going to experience more resistance the longer the wire is. So the answer is C, it increases. What is the unit of electric charge? So we've written that already. So hopefully that's a quick one. Let me know. Yep. Nice one. It's going to be A. That's for current. That's for resistance. That's for energy. Answer's Coulomb. So we've written that in our notes already. Okay. We've got a small calculation here. What is the potential difference between 2 points in a circuit with a current and a resistance? So we got potential difference of V, current I, resistance R. What do you think the answer is? Yes, people are getting it. So you'll do the equation V is equal to IR. So you'll do 2 times 3, which gives 6. Amazing. Well done, guys. So the answer is C. What is the purpose of a diode in an electric circuit? Okay, let's go back to our notes. Out of all of these, which one is the diode? Let me know. We'll start filling some of these in. So this top one's a cell. Second one's a battery. That's when you have 2 cells. You call that a battery. We've got bulb or a filament lamp. This one is an ammeter. We got a voltmeter. So what's everyone saying? 12th one. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, you guys are absolutely right. That's a diode there. Play symbol. So that's an open switch, closed switch. Come back to the rest in a second. Let's go back to that question. So purpose of a diode. What is the purpose of a diode? So this is the symbol. Sometimes you see it with a circle around it as well. Answer is, so it's not to resist current. That's a resistor. We've already mentioned that. It's not to store energy. That's actually something you don't even learn in GCSE. That's something you learn in A level. So most people are saying C. Yep, well done, guys. To allow current to flow in one direction. It only allows current to flow in that one direction. If you want to memorize that, think of this as an arrow. See here, we've got an arrow. It's only allowing current to flow in that direction. If it tries to flow in the other direction, the resistance is very high and it stops. It basically stops the current. Okay, we've got an exam question here. A student investigated how the current in a resistor varies with potential difference across the resistor. The student connected ammeter and voltmeter into the circuit. So, how should the ammeter and the voltmeter be connected? So we'll see how current varies in a resistor. So which one do you guys think it is? Let me know. So this is A, this is B, this is C, this is D. Comment your answer, tap on the screen a few times and let me know what you think the answer is. People going, so we've got a few people with C. Anyone disagree? So C, it says ammeter in series, voltmeter in parallel. Yes, that's right. Let's add that to our notes as well. So ammeter needs to be connected in series. That means everything has to be in the same loop. Voltmeter needs to be connected in parallel. So the answer is going to be this. Student increased the resistance of the variable resistor. So actually, let me actually add the ammeter into the circuit. So ammeter will be there. Voltmeter will be something like this. It'll be branched off in parallel to the resistor. It's asking to the resistor. It's not asking for the variable resistor. The one with the arrow is a variable resistor. How did increasing the resistance affect the current in the circuit? What does that usually do? What does current usually do? When you increase resistance, yes, thank you, it decreases the current. That's 1 mark there. How should the student change the circuit to give negative values for the current and potential difference? Negative values. So it's got an ammeter here, a voltmeter here. So the ammeter might read something like 5 amps, but we want it to say minus 5 amps. The voltmeter might read 10 volts. We want it to say 10 volts. What can you do? Yes, you can flip the battery. If you switch the battery around, so it looks like this, where the long side's on the left instead of the right, then that's going to change the direction of current into the negative direction. So you just say reverse the connections of the cell. Well done. On to the next one. Let's check the mark scheme first. Double check. We've got ammeter in series. Yes, we've done that. Voltmeter in parallel. That's fine. Current decreased. Do not say slows down. Some people would say current slows down. See there? Mark scheme says don't say that. Reverse the connections of the cell, or you can say battery as well. Reverse the battery, something like that. What is the unit of electric power? Everyone vote and tap on the screen. Could you do revising on atomic structure and atoms? Yes, I can do that. What is it? So tomorrow is going to be biology. So next week, maybe I can do that then. Yeah, I use a Apple Pencil on my iPad. So I'm using Good Notes and I'm using an Apple Pencil to write all of this. What time are my lives? 8:30 on a Friday. So that's today. And on Saturdays at 5 p.m. Thank you guys. So we're voting for D. D is correct. Which device is used to measure electrical current? That should be an easy one. Ooh, we're getting a mix of answers here. We've got voltmeter, we've got ammeter. Oh, correcting it. So we're deciding between B and A here. We got more people saying B. Ammeter. Yeah, current is measured in amps. That's one way to remember it. So you need an ammeter to do that one. What is the relationship between voltage, current, and resistance in Ohm's law? This is just one of the equations that we learned. You need to memorize this. So it's going to be, yes, most people are saying it. It's going to be V equals IR A. Nice. Okay, on to an exam question now. Name the type of relationship between current and potential difference for a resistor at constant temperature. That is, if you don't remember, the IV graph that we drew earlier. So the IV graph for a resistor. So if you remember, the resistor was a straight line through the origin like so. What relationship is that? So this is a bit of maths. There's a bit of, they can ask this in biology, chemistry, physics, and maths. If you have a straight line through the origin, well done guys, it means it is directly proportional. Okay, so remember that for all sciences and maths, straight line through the origin is directly proportional. Next question, write the equation which links current, potential difference, and resistance. We've done that already. Literally the last question that we did. V is equal to IR. It's fine. You can just write, you can use it. You can just use the letters. That should be fine. So here's another tip, guys. When you get, see here, we got part D, part E, part F. Whenever you have parts like carrying on one after the other, and they ask you to like state something like an equation, it probably means you're going to use it in the next part. It's a clue. That's the clue. V equals IR. We're probably going to have to use it in this calculation because look here, the current in the resistor was 0.12 amps, potential difference. So we've got resistance. No, we got I and we got V, and we want to work out the current. No, we want to work out the resistance. I is 0.12, V is 3. So yes, let's rearrange that equation. V equals IR. So R is equal to V over I. We move the I to the other side of the equation. 3 over 0.12, which gives a final answer of 25 ohms. Yes, well done, guys. 25 ohms, that's correct. Let's check that with our mark scheme. Directly proportional. That was fine. You can write the equation in full, or you can write V equals IR. That's what we did. That was fine. We rearranged the equation. 25 ohms is fine. If you even write 25 ohms without any working, you should get 3 marks according to that as well. Hopefully this will help you for your physics mock on Monday. Paper 1, yeah, this should come up, isn't it? Next question. Which of the following is a unit of energy? We should know this. We've written this in our notes. So drop a comment, tap on the screens. Yep, B, joules. What is used to measure power? We've mentioned that. Coulomb is for charge. What's Newton for? Can someone remind me? It's not even this topic. But what's Newton used to measure? Force, yep. You can say weight as well. Weight is a type of force. But any force is measured in newtons. So that's joules. How does the resistance of a thermistor change with increasing temperature? Right, where is a thermistor in our list? Can anyone tell me which one's a thermistor? It's going to be one of these ones. One of the ones that we haven't done. So it's either 1, 2, 3, or 4. 10th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is the 10th one. Well done, guys. The one with the hockey stick in it is the thermistor. So what's the one above it called? So not hockey stick. We've seen this actually in another question. When you have a resistor with an arrow through it, that's a variable resistor. Yep. What about the one under thermistor? No, this one's not an LED. This one's not LED. So this is the one that people get confused. People get confused. This one and this one. Okay, so let's look at the differences. The main difference is the arrow. We got an arrow going in here. We got an arrow going out here. And also what's in the middle. In the middle here, we've got a diode. Remember, a diode looks like a triangle. Here in the middle, we've got a resistor. So the top one is a type of resistor. It's an LDR, light dependent resistor. Bottom one is a LED. What does LED stand for? Light emitting diode. Yep, well done. So the way to remember that is the arrows. If this one's emitting light. So this one's emitting light. So it's giving off light. So that means the arrow is going to go outwards because it's giving it off. This one is dependent on light. So it's taking in light. So the arrow is going in. And also the main thing is that in the middle of this, we've got a resistor. In the middle of the other one, we've got a diode. So that's the main way to remember that. Okay, well done, guys. So how does resistance of a thermistor change with increasing temperature? So for a thermistor, what happens, guys? What does a thermistor do? Anyone know? These two are quite similar in their functions. So it's like a light dependent resistor. Controls temperature? No, loads of people think that. It doesn't control temperature. A thermistor doesn't control temperature. It does something else. It's a resistor. So think about what a resistor does. This provides resistance to a circuit. It slows down current. A fixed resistor always has the same resistance. A variable resistor, you can change the resistance. A thermistor is a resistor which changes its resistance based on temperature. So if it's really hot in the surroundings, if you have a thermistor and it's really hot in the surroundings, it means the resistance is going to go down. If it's cold, the resistance is going to go up. So it's all dependent on the temperature of the surroundings. Let's write this slightly differently. So let's say as temperature of the surroundings increase, resistance decreases. Whereas for an LDR, it's the same thing, but instead of the temperature of the surrounding, it does the light intensity of the surroundings. So here, as light intensity of the surroundings increase, resistance decreases. Okay? So remember that. Let's use that to answer our question now. How does the resistance of a thermistor change with increasing temperature? So it means the temperature of the surroundings. What did I say? What do you guys think the answer is? Comment and tap on the screen a few times. Well done, guys. B, it decreases. So the hotter it gets, the lower the temperature, the resistance gets. What happens to the current in a circuit if the voltage increases but the resistance stays the same? Let me know what you think. I'll give you a clue. It might be useful to use an equation for this. So what happens to the current? Voltage increases. Voltage is potential difference. What happens to the current but the resistance stays the same? So we've got a mix of answers. We've got B and we got C. Let's try and use our equation. V equals IR. So let's say we've got a potential difference of 20 volts. We've got, let's use easier numbers actually. Let's say we've got a potential difference of 1 volt. We have a resistance of 1 ohm. Okay. So that's going to give us 1 amp, because 1 times 1 is 1, right? So let's say if the voltage increases, so let's say we increase this to 2 volts, but we keep the resistance the same at 1 ohm, sorry, what's happened to the current then? How is this equation going to make sense? So before it made sense because 1 amp times 1 ohm was 1. Here, to make 2, you need it to be, yep, well done. I think everyone's getting it now. It's going to be 2 amps at the top. I don't know if you guys can see. But yeah, it should be 2 at the top. So the answer is it increases. Well done, guys. That was a tricky one. Right, question. So this is carrying on from our last exam question. So hopefully we don't need to use the information from before. When the potential difference across a filament lamp was 0.75 volts, the current in the filament lamp was this. Calculate the power. They're being nice here. They've given you the equation. Remember, you need to remember these. P is equal to IV. So we just need to sub in the values now. Let's check remember to check your units are correct. That unit is correct. That unit is correct. So we just need to do P equals IV. No, it's not triple science. This is in combined as well. I think these questions were from a combined paper. But it's all of triple science do need to know this as well. You do not get given the equations in the exam. So in your mocks, I don't think you'll be given the equations. You need to memorize them all. So I've got all 6 in the notes for electricity. These are the equations you need to know for electricity. So anyone got an answer for this? We're going to use P equals IV. So we need to multiply our current with potential difference. And yep, we're getting an answer of 0.12. So we're doing 0.75 times 0.16, which gives us an answer of 0.12. Well done. Yep, I'll be doing electrolysis at some point. I know it's one of the harder topics. People really don't like it in general. Next question, write down the equation which links Q, I, and T. Q equals IT, we've written that down already as one of our equations on our list. So, yep. That was fine. Q equals IT. You can write it in words as well. That's fine as well. Well done. What does a voltmeter measure for the next question? So we're nearly done here, guys. We've got one more exam question, a few more multiple choice question. Voltmeter measures, obviously, voltage. But in your exams, they probably won't word it as voltage. They'll call it something else. They'll call it potential difference. They don't really use voltage anymore in GCSEs. So answer is C. What happens to the brightness of the bulbs in a series circuit if more bulbs are added? So we have a series circuit, we have one bulb, and let's say we added another. What's going to happen to the brightness of the bulbs? Let me know what you think the answer is, and tap the screen a few times. So, yep, everyone's saying decreases. Yes. If it was in parallel, it would stay the same, the brightness would stay the same, but in series, they decrease. The current gets... the potential difference gets split between them. All right, last exam question here. 3 marks. It's carrying on from the last question. The manufacturer increased the current of the filament lamp to 200 milliamps. Calculate the charge, 15 seconds. So what do we have here? We got milliamps, which is current. Charge is what we're trying to find out. And we got 15 seconds. That's a time. Which equation I'm going to use here, and what do we need to remember to do for this one before we put the numbers in. So yep, Q equals IT. We need to remember to convert it. So before you put any numbers in, always check whether you need to convert anything. This is milliamps. We need to convert from milliamps to amps. It's like converting millimeters to meters. So if you're going to do that, you're going to divide by 1,000. If you're going to go from amps back to milliamps, you're going to times by 1,000. Here, we're going from milliamps to amps. So we're going to get our 200 and we're going to divide by 1,000. 200 divided by 1,000. That gives us 0.2 amps. Now we can put that into our equation. Q equals IT. So we do 0.2 times by 15. We gives an answer of 7.5. No, sorry, not 7.5. I don't have a calculator on me, guys. It's 3 coulombs. It's a fifth of 15. Final answer is 3. Part H. The manufacturer increased the current in the filament lamp from 200 milliamps. The filament in the lamp broke when the current reached 320 milliamps. How many times greater than the 200 milliamps was the current at which the filament broke? So how many times bigger is 320 from 200? This is like a maths question, guys. From 200 to 320, what do you need to do to get from 200 to 320? How many times do you need to multiply it back? It's not asking how much you need to add, because it's saying how many times greater. What do you need to multiply it by? So what you can do, if you want to do it as a calculation, 320 divided by 200. And if you do that, yep, well done, guys, you get 1.6. So it's 1.6 times greater. So if you get 200, times it by 1.6, you should get 320. All right, guys. So that's the equation. Let's quickly check the mark scheme. Yes, conversion gets you a mark. Then you times it by 15, you get 3. And then we get 1.6 is a 1 mark, so there's no calculations really needed. And then we got one more multiple choice question. Let me know what you think this is. So while you guys vote on this, let me know what topic you want to do, if there's any topics you guys want to cover. And also, if you want to look back on this live, go onto my YouTube. So it's Flash Revision Lab on YouTube. I uploaded the cells live from last week, and I'll be uploading the moles one as well from last week. Every live I'm going to upload these questions, all these questions, in the form of like the way they look now, but there's also another form where it looks like flashcards. So if you really want, you can print them out and you can cut them out. So the answer, if you cut them out and then stick them together, you'll basically make a flashcard. So you have the question on one side, you flip it over, the answer will be on the other side. You guys can check it out. It's on my YouTube. Go on cells. I had a live on cells, the specialized cells, in the comments. Not in the comments, in the description. There's all the links. So we have the notes, we have the questions, and we have the flashcards as well. So give it a shot. Thank you, guys. It means a lot when you to know that it helps you guys. So yeah, so we got, what did you guys ask for? Let me check the comments. We got organic chemistry, some people asked for electrolysis. Tomorrow's biology. I'll let you guys know. I don't remember what it was going to be on, but it's at 5 p.m. I'll put it on my story, whichever topic it is. And yeah, so final question, what did you guys put? What device is used to measure potential difference across the component? Potential difference is basically voltage, and what you'll need for that is a voltmeter. Well done, guys. It looks like almost, yeah, everyone got it. Okay, guys, I'm going to head off, but I'll be back tomorrow to do biology, and I'll let you guys know what topic I'm going to do next. So yeah, I'll try and keep doing this as regularly as possible on Fridays and Saturdays. If I can, I'll try and do an extra day or something, but I'm not sure if I'll be able to anytime soon. So tomorrow at 5 p.m, guys. See you then. Thank you so much. Bye.